Hi, welcome back. In this video, we're going to talk about how to solve a rational equation. Now, in the previous two videos, we talked about how to simplify expressions. We're going to take what we learned from multiplying and dividing and from adding and subtracting, and we're going to apply it to this video, where we are now actually solving something, and we're solving for the value of x. So, we're going to do 4 examples of different complexities, so feel free to stop, pause, take notes, and let me know if you need anything. All right, so here's an example. Right? We're going to solve this rational equation. Note, in the previous video, we had examples that did not include the equal symbol. And it was just, can you simplify this? Can you add them? Can you find the least common denominator? That kind of thing. But now we're going to add an equation to it, an equal symbol, so that we can solve for x. But before we solve for x, we need to know that when we're solving a rational equation, we need to account for any numbers that are not defined. What do I mean by that? Well, a rational number is defined as a number that can be expressed as a fraction such that b is not equal to 0. So we can divide by any number. We can divide by 1, by a negative, by a whole number, by positive. We just can't divide by 0. So I want to find out, where does the error occur when I start to divide by 0? So like, I cannot divide 2 by 0. Or in this case, plus 1 by 0, right? Because that will never give me 1. These two numbers are undefined. So I want to find out, where do these errors happen? And they happen here. Anywhere that we have a denominator, what we're going to do is we're going to set that denominator equal to 0. And I want to know, well, when does this x equal 0? And if I solve for x, I know that when x equals -1, this will create an error, right? -1 plus 1 is 0, and now we're up at an undefined value. Similarly, with x minus 1, if I set that equal to 0, I can see that when x equals 1, if I plug 1 in here, you're going to get 1 divided by 0, which also creates an undefined value. So we're going to start by deciding here, what are my restrictions going to be? Right? My exceptions. Before I solve for x, I need to know that these two numbers are going to create an error if they're part of my solution. So x cannot equal -1 and +1. Those are my restrictions. Now I'm going to solve for x. Yeah? And then I'll walk you through this process if I need to. So let's solve for x. What did we do in our previous video? When we were adding two different fractions of different denominators, we need to first find the least common denominator. And since they're different, we're going to multiply them. That's going to be my least common denominator. So for the first fraction, I already have the x plus 1. I need to multiply it times x minus 1. And I'll do that in the top as well. For the second fraction, I already have the x minus 1. Now I need to include the x plus 1. So I'll multiply the top and the bottom times x plus 1. Yep. Now that we have a common denominator, I can merge these two fractions into one. So I have this left part of the fraction, 2 times x minus 1, plus 1 times x plus 1. Right? Now the goal is to merge things and combine like terms. So let's distribute. We're going to get 2x minus 2 plus 1x plus 1, all divided by x plus 1, x minus 1. As I combine like terms, 2x plus 1x is 3x. -2 plus 1 is -1 over x plus 1 times x minus 1. Right? So far, we've been doing what we've been talking about in the last two videos, right? So far, we've been focusing purely on the left side. Can you merge the two fractions with a different denominator? And when we merge them, we come all the way down to here. Now, here's where we can start to solve for x. Yeah? So, if I want to solve for x, I need to get rid of the denominator. Since I'm dividing by this, to get rid of it, I do the inverse. I need to multiply both sides. Times x plus 1 and x minus 1. Multiply the side as well. This allows me to cancel these two nicely. And now I have no fraction. Now I have 1 times all of this. Now 1 times anything doesn't really change, so I'm just going to write it as x plus 1 times x minus 1. Right? 1 times all of that is just that. And my goal is to solve for x. So I got to do FOIL method, right? I got to distribute 3x minus 1 equals what? X squared minus 1x plus 1x minus 1. I'm just multiplying. These are going to cancel out, leaving me with 3x minus 1 equals x squared minus 1. Now, as I'm solving for x, I realize that this is a quadratic. And with quadratics, I have to remember that one method for solving is factoring. So let's move everything to one side for us to be able to factor it. Let's move this 3x to this side, and let's move the 1 to the other side. All of these leave me with 0 equals x squared minus 3x, and these cancel to 0. Right? So you can add a plus 0 if you want, so you can find the factors there. I'm going to continue solving the problem up here, just for space purposes. So 0 equals x squared minus 3x plus 0. What are my factors going to be here? Well, I can go about it using this method, x times x, and 0 times negative 3. Yeah, this gives me negative 3x, 0x, that definitely adds up. So my factors are x plus 0, or just x, right, times x minus 3. Now that I've separated these x's, I can solve for x. X equals 0 and x minus 3 equals 0, right? I'm allowed to separate these two terms now. So I have my two solutions. X equals 0 and x equals 3. Now I gotta always go back and check my restrictions. Remember that my answers cannot be negative 1 or 1, because that creates an undefined solution. Thankfully, neither of these are part of my restriction. So they're both acceptable as my solution. I have two solutions here, x equals 0 and x equals 3. Now, how much of this problem, right? Half of this problem was what we did in our previous video. All of that was find the least common denominator and combine like terms. The new part is solving for x. So if you need help with this portion, feel free to watch my previous video on adding and subtracting rational expressions. Let's try another example. So before we begin, I must first identify my restrictions. Right? What x values will not be allowed as part of my solution? Well, when is this and this going to equal 0? The first one, I say x plus 2 equals 0, and the other one, x equals 0. I'm going to set my restrictions first. And this always happens with the denominator. Because again, I can't divide by 0. And when I solve for x here, I get negative 2. Right? If I plug negative 2, I get negative 2 plus 2, which is 0. I can't divide anything by 0. So x cannot equal negative 2, or an error will happen. At the same time, x cannot equal 0, because 1 divided by 0 is also an error. So x can't be neither of these. Right? Let's solve this problem and see what we get. Now, for solving, the first thing we want to do is we want to combine these two fractions. So we need our least common denominator. Since they're both different, it'll be x times x plus 2. That'll be my least common denominator. Right? We talked about it in our previous video, so feel free to check that out if you need some help. So for the first fraction, I got x plus 2. I need to multiply the denominator times x. which means I need to multiply the top times x as well. For the second fraction, I already have an x. I need to multiply it by x plus 2. So I need to multiply the top times x plus 2. Right? Now that they have a common denominator, I can merge these two fractions together. X times x is x squared minus all of that, minus 1 times x plus 2. I can now merge the two equations. Right? And all of that should equal 1. I can still simplify by using the distributive property, x squared minus 1x minus 2, all divided by x times x plus 2. Yeah? Now, all of this has been simplifying the left-hand side. That's all we've been doing. Right? Once it's simplified, I can start to solve for x. This is now solve for x. All of this was simplifying. So I can break this into 2 steps so far, right? The first step is to simplify the fractions, find the least common denominator, combine everything as much as possible. Now to solve for x, let's get rid of that denominator. Let's multiply both by x times x plus 2. And over here times x plus 2. These cancel out nicely, leaving me with just with x squared minus 1x minus 2. Over here, 1 times x is just 1x, right? This is just 1x times x plus 2. I can distribute. This gives me 1x squared plus 2x. Now remember, the goal here is to solve for x. So I'm going to combine like terms, right? That's my whole purpose here, solving for the value of x. And this is like some sort of quadratic. So as I move this x squared to the other side, they cancel out nicely, leaving me with just 1x minus 2 equals 2x. I don't have to factor this problem because there's only one x variable, so let's move this 1x to the other side. Plus 1x. This gives me negative 2 equals 3x. And to solve for x, we divide both by 3. X equals negative 2 thirds. Now, is this part of the solution that I should be ignoring? As long as x is not equal to negative 2 or 0, which is not this, I have a solution. Okay? I'll explain more as an example here in a little bit as to why this is necessary. But so far we haven't had any restrictions. All problems have worked out just fine. All right. Here we have a scenario. Okay. First thing I want to do, first of all, by this point, ideally you pause the video, you try solving it and see if we're getting the same solution, right? So, what are my restrictions? Set the denominators equal to 0. And there's only one unique value here, right? X minus 1. Set it equal to 0. When I move this over, x cannot equal 1, right? 1 minus 1 is 0, and that's an error. 1 minus 1 is 0, that's an error. So, let's solve. To solve, I want to merge these two fractions together. Technically, this can be expressed as a fraction, right? Just 2 over 1. How do I merge these two fractions? Well, first, let's find the least common denominator. Both fractions should have the same denominator, which is just going to be 1 times x minus 1. They both need to have that in the bottom. So how do we make that happen? Well, I need to multiply it times x minus 1 in the bottom and the top. Right? Technically, I have a 1 here. 1 times that minus 1 over x minus 1. Now that I have the same denominator, I can combine the two fractions. Right? 2 times x minus 1 minus 1 all divided by x minus 1. Right? 1 times that is just that. Nothing changes. I can now distribute and combine like terms. And that gives me 2x minus 3. Right? All I'm doing here is combining the two fractions. I'm simplifying. That's really what I'm doing. Now, I didn't change anything over here, so I'm just going to copy this fraction. I'm just going to bring it down. That should equal x over x minus 1. Yeah? All right. Here's where the solving begins. Solve for x. Right? LCD was this step. Now here, if I'm dividing by x minus 1, I can multiply this by x minus 1. If I'm dividing, I can multiply. So it's now that we only have 1 on each side, each fraction, we can get rid of both denominators by using cross multiplication. By cross multiplying, the denominator now goes into times, right? The opposite of division is multiply. I have x times x minus 1. When I multiply these, I have 2x minus 3 times x minus 1. Cross multiplication allows me to get rid of both. And you know what? Technically, that's the same thing we did before. Right? Except that over here, there was no fraction to cross multiply. But notice how the denominator went up top. Yes. All right. Here, I'm going to distribute, FOIL method, all this stuff, right? My goal is to solve for x. So as I distribute, I can now get rid of parentheses. This gives me 2x squared minus 2x minus 3x plus 3. Negative times a negative is a positive. All right. I can combine like terms. This turns into negative 5x plus 3. I notice that there's a quadratic here, so I'm going to put everything on one side and factor. So let's move this x squared to the right, and let's move this 1x to the right. These two cancel to 0, right? 2 minus 1 is just 1x squared. Negative 5 plus 1 is negative 4x, and the plus 3 stays by itself. As you solve for x, right, this one requires you to factor because it's a quadratic, right? But it's all solving for x. Sometimes you don't factor. Sometimes you just solve for one x value. Here we're solving for 2 because that's what this problem gave us. So what are my factors here? X times x and what? Negative 1 times negative 3. Negative times a negative is a positive, but then when you cross multiply, negative 1x and 3x, right, gives you negative 4x. So my two factors are x minus 1 and x minus 3. 0 equals x minus 1, x minus 3. Right? Factoring allows me to separate these two. So x minus 1 equals 0, x minus 3 equals 0. Let's solve. When I move the 1 over, x equals 1, and when I move the 3 over, I get 3. I have two solutions, but remember, from these two, I had a restriction. X cannot equal 1, which is this one, which means this is called an extraneous solution. We're not going to use it. We can use this one for sure, though. Why can we not use it? Well, if I plug 1 back into the equation, this is what I get. I get 1. Yeah, let's move this over here. 1 divided by 1 minus 1. Does that equal 2 minus 1 over 1 minus 1? What's 1 minus 1? Get 1 divided by 0. 2 minus 1 divided by 0. This is an undefined value. It doesn't exist. I can't solve this problem when x equals 1. That's why we ignore that part of our solution. And we call it an extraneous solution. It means that we were able to solve for 2x values in this equation, but this one makes this equation not real. It makes it undefined, right? It creates a value that does not exist. So it becomes extra. We don't use it. It becomes as a byproduct, right? The one we can do is 3. Because if I plug in 3, I don't get an error, right? If I plug 3 in this equation, I'm going to have 3 divided by 3 minus 1, 2 minus 1 over 3 minus 1. If I simplify, this is just 3 over 2. And over here we get 1 minus, what is this, 1/2? And then 2 minus 1/2. Let's move this over here. I get 2, this is just, I can rewrite that as 4 over 2 minus 1 over 2, right? And 4 minus 1 is 3. So 4 minus 1 is 3/2. See how that one works? 3/2 does equal 3/2. That's why that one is acceptable. All right, last example. First, I need to find my restrictions, right? What are going to be my restrictions in this problem? Well, when is this going to equal 0, and when is this going to equal 0? Let's find out. Set them equal to 0 and solve, right? When you move the 4 over, you get x squared equals 4. Remember that when you square root, you're going to get plus or minus 2. Over here, when you move it over, you get negative 2. So x cannot be either of these solutions, positive or negative 2. So as I solve for this, as long as it's not either of these, we're good. Now, for this problem, do I need to find the least common denominator? Am I adding or subtracting these fractions? No, there's nothing to merge. Like over here, we did have to do that, right? We have to combine 2 fractions first before we can get there. Here, there's nothing to combine. There's only 1 fraction on the left and only 1 fraction on the right. So to get rid of the denominators, we can just cross multiply. X times x plus 2 and 1 times x squared minus 4. Fractions are gone. Let's solve for x. As we distribute, you get x squared plus 2x. And here you get 1x squared minus 4. Let's combine like terms, right? What do we get here? Well, when I move the x squared over, 2x equals negative 4. Let's divide both by 2. X equals negative 2. Is this an acceptable solution? No. It's part of my red flag part, right? Which means this cannot be a solution. That one becomes an extraneous solution. It's a solution that is solved in the equation, but it creates an error, right? Because plugging in negative 2 here would be 1 divided by 0. It creates an undefined solution. Now, since there was only one solution and it was extraneous, we say that here we have no solution. Because every answer we got was part of my restriction. So this means that this fraction cannot ever equal this fraction and create a real number. A number that we can graph, that we can quantify. Does that make sense? Alright, let me know if you have any questions. Don't forget to like and subscribe. And as always, I'll calculate later.